learning to take a word problem scenario and turn it into an algebraic expression, that is, an expression with a variable and an operation and some numbers, is a super important skill. So let's take a look at a few word problems and decide how we would write those algebraic expressions. Danny bikes 5 miles every day. Notice how there's no obvious, then you add, then you subtract, then you multiply, then you divide. So what I like to do is do like a little guess and check problem and figure it out for myself. So every day, if Danny bikes 5 miles in one day he bikes 5 miles. In 2 days he'd bike 10 miles. In 3 days he'd bike 15 miles. And once I have a little bit of information on the page, I can see, oh hey wait, I would multiply times 5 to get my answer. Okay, so I know this is going to be a multiplying problem. Next thing I have, some problems will tell me let D equal the number of days, and some won't, depending on if it's a multiple choice or like an open free response. So if there's nothing there, you have to define your variable. You have to write me a little mini sentence that says D, or whatever other variable you're choosing, equals number, and that hashtag is actually a number sign, so you can write that, number of days. Alright, now I know if I have D number of days, however number of days they are, 1, 2, 3, 1 million, I have to multiply it times 5. We're in math class and numbers are more important than letters, so the number, the numeric coefficient, always comes before the variable. The nice thing about multiplication is it's like when you have parentheses, you don't have to write a times sign. You don't have to write 5 times D. You don't have to write 5 parentheses D. The math world has just agreed if we see a numeric coefficient, a number that comes first, and it's smushed up real close with a variable, and we can't see any plus or minus or divided by signs, we know that that means multiply. So 5D, 5 times D, would be my algebraic expression. The only thing you need to be careful about is if it gives you 5D and then it says, hey, how many miles would Danny go if he biked for 12 days? You need to be really careful when you're plugging it in, because you don't want to just go like that and be like, oh, 512 miles. No, you know that's multiplying in there. So when you're plugging in a number for your variable, you just need to go ahead and like somehow add in something that tells you that you're multiplying them. Okay. Next one. Crystal shares her snacks equally among her 3 friends. Aw, so nice. Okay. Might make a little chart. Snacks. How much does each friend get? Now this one is a little bit, there are some keywords that might help make it a little bit easier. No, not snacks. Shares equally. That tells me that I'm pretty sure that we're going to be dividing, but let's just double check. Let's say Crystal brings in 3 snacks. She brings in 3 snacks, shares equally with her friends. Here are her 3 snacks. Here are her 3 friends. Well, they kind of look like starfish. Great friends, Crystal. 1 for you, 1 for you, 1 for you. That means each friend gets 1. If Crystal brings in 6 snacks, that means that each friend would now be getting 2. If she brings in 9 snacks, each friend would be getting 3. If she brings in a number that's not a multiple of 3, like she brings in 10 snacks, then each friend would be getting 3, and then you'd have to break up another one, and so you could have like fractional amounts of a snack, right? The thing we want to be careful with is saying that we are going to be dividing the snacks divided by the friends. Not the friends divided by the snack, because we really don't want to chop up Crystal's friends and give them to the snacks that she brought in, because that would be murder, and I don't think the snacks would actually eat them, so it would totally be a waste. So we have to watch out about which one comes first. That's why this chart is so helpful, because you can then say snacks divided by 3 equals friend, how much each friend gets. Divided by 3, okay, divided by 3. I didn't define a variable here for you, so you're going to have to go up there and write me S or whatever letter you choose. If your name starts with a B and you always want to use your variable B, you can. S is easier for me because I see S and I know the problem is about snacks, and it makes it a little bit easier. S equals snacks, or the number of snacks. Am I taking her 3 friends and dividing them up and giving them to the snacks? No, don't murder people. I am taking the snacks and dividing it up between Crystal's 3 friends. It's okay if I chop a snack up, because it's going to get smushed up and in your stomach anyway. Not so good if I chop a person up. So that would be my expression right there. Another way to write division, which you'll see very commonly, is to write it in fraction form. This is also perfectly acceptable. That means snacks. Fractions are always division problems. Snacks divided by 3. And you'll see that form a lot in algebra, so get used to both of them. Let's try another one. No matter how many problems he has, Justin's mom always helps him with 3 of them. How many does Justin do alone? I'm going to start by defining my variable. Well, 3 is like a constant number, so that's not going to change. But the number of homework problems that Justin has, that might change each day. So I'm going to say P equals the number of problems. If you wanted to write like a full sentence, you could say, let P, or let the variable P represent or equal the number of problems, but really, so long as you write me, here's my variable, equals sign, here's what it means, that's enough. Okay, I'm going to make myself a little chart just to make sure that I'm getting it all right. Number of problems, which since I already defined my variable, I could just say P. And then number that Justin does alone. Okay, let's say today Justin has 10 total homework problems. Mom helps him with 3 of them. Justin has to do 7. The next day Justin has 200 homework problems. Oh my gosh, really big day, studying for a huge test. I would never give 200 homework problems, but maybe that's like all together total. Mom helps him with 3, so now he has 197 to do by himself. Sorry, Justin. Let's say that he has 3 homework problems. Mom helps him with 3. He has to do 0 by himself. Interestingly, mathematically, we could say, let's say Justin has 1 homework problem. Mom helps him with 3. Does Justin really do -2 homework problems by himself? No, Mom can't even technically help him with 3 because he only has 1. So, while mathematically this does work out, oopsie, went backwards. In real life, when you really think about it, those numbers don't make sense. So you got to be careful with this, because sometimes you can come up with accurate math that does not represent accurate real life. So we said P is the number of problems Justin has. We are always going to subtract 3 because those are the number that his mom helps him with. So P minus 3 would be our answer. Every week Ola buys X pieces of chocolate. Here's an example where the variable is already defined for you in the problem. You do not need to write X equals the number of pieces of chocolate because it's already right there. This means you do have to use the letter X. You can't change it now. It's already defined in the problem. Ola buys X pieces of chocolate and 4 bags of gummy bears. Okay, so how much candy, sorry I forgot to put in that, how much candy does Ola have? So here we got to make some stuff up. X pieces of chocolate, total candy. Let's say that she only buys 1 piece of chocolate today. And then she has her 4 bags of gummy bears. That's 5 total pieces of candy. But let's say she's being nice. She's going to get lots of candy for her sisters. Today she's going to get 10 pieces of candy plus her 4 bags of gummies. 14 total pieces of candy. The next day she's only going to get 3 pieces of chocolate plus the 4 bags of gummies. That's 7 total pieces of candy. Here we can see this is going to be an additive relationship. We are adding plus 4 to each of these. So our expression would be x plus 4. That would give you the total number of pieces of candy. Those are a few examples of writing algebraic expressions. The one more thing I did want to mention, which is super important, and only the people who stuck with me to the very end of the video will get to hear it. We just wrote expressions. When you write an equation, there's one key word that will really help you know the difference between an equation and an expression, and that's the word is. So if you see in words, if you see a problem in words that's saying which one of these is an expression, which one of these is an equation, x plus 4 would be written as x plus 4. N minus 2, just like it sounds. J is 12, would look like this. R divided by 7 could look like either of these. This one right here is an equation, not an expression. And if anybody's watching this before our quiz on Monday, congrats to making it to the end of the video. Hint, hint, remember this. All right, bye.